Good morning, all the students. So today we're going to start with almost the last part of basically energy resources, what we are discussing in the last class. That's if you remember what we covered in the last class, that is biomass based. Okay, biomass based energy. Biomass energy sources. If you remember, last time we have covered all these things in detail. Initially, okay. So now today we're going to discuss this thing, the basically how biomass energy is being produced using biological routes. So I told you basically it's a biochemical conversion where you're going to use a microbial mass or biomass. Biomass is basically active. Biomass means active microorganisms. Okay. So they generate mostly, I told you in the last class, they generate mostly methane and carbon dioxide. And you need to improve this impurity, remove these impurities a bit. If you can use as such, there's no any harm. But you will not get as good calorific value as good you are getting after purification. So these gases can be burned directly, or they can be upgraded to pure fuel by removing these impurities, methane and some other impurities. Okay. So basically what I'm talking about, you're talking about now, the carbon-rich fuel, which is being produced anaerobically or aerobically from this kind of method, and where you are using substantially using a biomass, which is otherwise is a waste. Okay. So this thing I told you last time, you have when you're talking about biogas is purely methane. I can say not purely methane, but majorly methane. Near about 60 to 70% content is methane. Remaining is carbon dioxide and some trace gases, ammonia, hydrogen sulfide. You want to remove these things, you have now sufficient methods. You have scrubbers, you have some other particular solutions which you can use to remove these kind of impurities. Okay. So I think so I stopped over here last time when I discussed when you want to produce a biogas, you must remember from a previous studies that you need certain plants, biogas plants, to hold these kind of or to produce these kind of gases, biogas from the biomass. So basically, when you talk about the biogas plants, there are basically two types of biogas plants. Although you can have majorly engineering modifications, you have different classifications in this category, but majorly they have two types: floating gas holder type and fixed dome type. Okay, floating gas holder type and fixed dome type. Okay, so these two things I will be discussing a bit with you in this today's lecture. And when you talk about hindrances in the success of biogas plant, because hindrance is basically a technical gap. So technical gap क्या है जो मैं आगे बताने वाला हूँ आपको. Because normally when you want to operate these biogas plants, में देखोगे आपने गैस नहीं बनती ऊपर से. फिर गैस बनती नहीं है, एक महीने या 10 दिन के बाद या 15 दिन के बाद जब डाइजेशन स्टार्ट होती है, you say it's not hygienic, it's not basically effective. But the point is you are not technically holding that kind of thing. You are not technically producing that. वो technical gaps क्या है मैं बताता हूँ. Okay. Culture practice, that वही है हमारा culture practice नहीं है हमारे पास. We are going to discard it. फेंक दो इसको. And whole biogas, basically biomass, which we are producing, can be converted to biogas by suitably designing these kind of plants. Okay, climate variation, social stigma, ये सब रहेगा इसके लिए. So recent years, like 10 years, like many biogas plants have been installed. Okay, and because this is again a clean fuel, you're going to use clean fuel biomass, which is otherwise a waste. You can use it for producing a gas, which is having very good calorific value. Okay, so these are the some parameters which I want to discuss, which are affecting the digestion of which biomass. Okay, so you need to look into these parameters when you're talking about the generation of biogas from the biomass. और बहुत ये upcoming field है as far as the technologies are being concerned. तो अगर देखोगे, अगर आप लिटरेचर में देखोगे, अब मैक्सिमम जो रिसर्च ओरिएंटेड वेस्ट टू एनर्जी में, और वेस्ट टू एनर्जी में ये सबसे बड़ा एस्पेक्ट है. वेस्ट टू एनर्जी, कन्वर्टिंग बायोगैस टू व्हाट, मैं बताने वाला हूँ टाइम. बट उसके लिए आपको जो प्लांट डिजाइन करना है, चीजें डिजाइन करनी है, तो पैरामीटर्स यू नीड टू टेक ऑन. take care of. Okay, like first is temperature, retention time, then your pH level, C by N, that is carbon to nitrogen ratio, proportion of dry matter, agitation. Okay, so these are the certain parameters you need to remember, these kind of parameters. Okay, temperature क्या होना चाहिए, temperature above and below है तो ये microbes will not be active, microbes will not be active, microbes will not be able to consume the biomass. When the microbes will not be able to consume the biomass, then they may not be able to do the digestion. When they are not able to do the digestion, they are not able to produce a desired gas, which we are requiring, the biomass, biogas, sorry. Okay. Then retention time. I will be discussing about these things. Retention time is you need to retain the biomass in the reactor for a sufficient amount of time, so that complete digestion should be there, so that after digestion methane can be produced. Okay. Then pH level, no doubt. You know very well, microbes, they work very well at a certain pH range. I will going to discuss, no doubt. If the pH range fluctuates, why fluctuates? Because जैसे से digestion होगी ना बेटा, whenever as digestion goes on, there will be formation of intermediate acids or sometimes ammonia, depending on direction. Okay, so this will lead to the fluctuation of either acidic pH or basic pH. Okay, so ये भी उसके affect करेंगे parameters. Carbon to nitrogen ratio I will be discussing, no doubt. And what is the proportion of dry matter? Dry matter कितना है? ठीक है? Then agitation. Agitation is just is just there to have a uniform mixing of the particular biomass, so that heat can be distributed. Number one. Number two, microbes can get to access, can get access to the fresh substrate again and again. जब mix होगा ना, एक जगह कंज्यूम हो जाएगा, मिक्स होकर नहीं आ जाएगा, वो कहीं और फैल जाएगा. So microbes also get distributed. Okay. So मैं बता चुका हूँ, if any of these determinants or parameters outside the acceptable range, the digestion we are looking forward is can be. Okay. If you talk about temperature, I told you basically, if you remember last time. Okay, the anaerobic digestion, fermentation. I can say fermentation. Okay, why I'm saying fermentation? Just hold on. So I'm saying fermentation. It's basically it's a fermentation. Fermentation means your microbes are active for converting or digesting this kind of biomass to get it converted to suitable end products, which are biogas and other things, which I will discuss. So they work better between temperature range of 30 to 70 degrees centigrade. Okay. So if it falls below or above, then you need to insulate the reactor. Insulation means you're not allowing the temperature either to cross that particular limit which is being set for the reactor. Okay. So depending upon the bacteria, depending on bacteria we're going to use. Okay. I told you, if you remember in the wastewater treatment plant, we discussed this thing. Three kinds of bacteria, means psychrophilic, mesophilic, and thermophilic. So they are work between a range of 20 to 40, and above. Thermophilic is they work well under above 40. Okay. So if this particular bacteria is prevalent in your kind of digester where the actual digestion is going on, if there is a fluctuation in the temperature, क्यों? आपको देखा कि जितने भी ऐसे biomass reactions होते हैं, they are exothermic reaction mostly. When they are an exothermic reaction, they're going to produce the heat, and they're going to produce the heat. The temperature rises. When temperature rises, no doubt the methane production is very much harder, because the microbes which are actually meant for production of biomass, biogas like methane, are totally sensitive towards this kind of changes in temperature. So temperature change means they are going to die. When they're going to die, so when microbe नहीं है वहां पे, तो digestion आपकी होगी नहीं बेटा. And similarly, you have pH. So again, the pH is the same thing, but okay. So you have optimal production is basically when pH is 7 and 7.2. Okay, there will be inhibition. Inhibition means there's a breakage, not breakage. It's a break on the production. Inhibit ho gaya wo cheez. So it can be inhibited either due to acids or due to the bases, or that is ammonia. Basically, I'm talking. So if the pH drastically decreases due to production of acid, and if the pH drastically increases due to the production of ammonia in systems, ammonia, okay, system में बनता है बेटा ammonia चीज, depending upon the reactions. So your pH may fluctuate from less than 6 or may get greater than 8. So in that case, you will get inferior gas quality or lower gas yield. Okay. Let's C by N ratio, beta. C by N ratio, I told you, beta. C by N ratio is basically I'm talking about, yes, carbon to nitrogen ratio. Beta, ये बहुत same active है बेटा. जैसे बेटा देखो microbes are living. I've told you specifically in the wastewater treatment also, ना? Microbes are living beings, and just like you, and you need a balance in your diet, like carbon, hydrogen, nitrogen, balance right here. Same thing is here also. You cannot give microbes only carbon source. They need nitrogen and other particular things also. मैं आगे बताने वाला हूँ. लेकिन majority of times जिस चीज पे वो depend करते हैं, not majority, every time it depend on C by N ratio. अगर आप बाकी न्यूट्रिएंट भी दे दो उनको, जो भी आगे दिखाने वाला हूँ, some micronutrients, but the carbon nitrogen is not maintained. They will not be consumed because their building block तो यही है, carbon to nitrogen ratio. Okay, so basically you have to maintain C by N ratio. तो कार्बन होनी बहुत जरूरी है. कार्बन किस फॉर्म में होगी बेटा? या शुगर की फॉर्म में या स्टार्च की फॉर्म में होगी बेटा. ठीक है जी. तो ये नहीं हुआ है चीज है. ठीक है. तो देखो तभी एक मैं आपको क्वेश्चन देखो आगे मूव कर जाऊंगा. पैडी स्ट्रॉ, व्हीट स्ट्रॉ में बहुत रिसर्च है. पैडी स्ट्रॉ पे कोई रिसर्च नहीं है. पैडी स्ट्रॉ को बंद किया जा. पैडी स्ट्रॉ को हम बायोगैस में कन्वर्ट नहीं कर सकते. पैडी स्ट्रॉ में मैक्सिमम सिलिका है. कार्बन कंटेंट बहुत कम है उसमें. इनऑर्गेनिक ज्यादा है वो. तभी पैडी स्ट्रॉ बंद कर दिया जाता है. देखा आप. Okay, so that's why the C by N ratio, the carbon nitrogen ratio is very much important. And if you're talking about methylogenic bacteria, and mostly when you're talking about methylogenic bacteria, they prefer a C by N ratio between 10:1 and 20:1. Means 20 parts carbon and 1 part nitrogen. For every 10 part, you need 1 part nitrogen. Okay, and you know nitrogen should not be very high, because if the nitrogen is very high, pH is, when pH is high, the growth of bacteria is inhibited due to toxicity level caused by the ammonia production, I told you. Okay? So you always want to get rid of these kind of things. That's why you always prefer mixed kind of substrate, because mixed kind of substrate always keep on balancing the nitrogen and carbon ratio all the time. If you keep on adding only one type of substrate all the time, sometimes inhibition will be there in terms of excess of nitrogen. Okay? And no doubt your mixing capability or mixing particular stirring the substrate is going to affect a lot to the digestion, in terms of it is going to remove the heat, it is going to remove the excess brine spores, it's going to reduce the scum formation and sedimentation. It's going to bring a fresh material in contact with bacteria again and again. देखो ये ना आपका ये इतना बड़ा रेक्ट है, यहाँ पे आपको चल रहा है, यहाँ पे जो मटेरियल बड़ा है वो एक्सपोज नहीं हुआ. When you going to mix it uniformly, तो अब ये इधर आ गया, ये इधर आ गया. This means ये fresh अब बैक्टीरिया एक्सपोज हो जाएगा. Okay, so that's why mechanical stirring or some stirring mechanism should be there, by which you can really mix the substrate so the heat जो प्रोड्यूस हुई है वो ट्रैप ना हो और वो डिसिपेट हो जाए हीट सारी. ठीक है ना. और फ्रेश वो आए और मेटाबॉलाइट्स रिमूव हो जाए. So there are so many benefits of this kind of thing. And these are the some essential micronutrients which are being required apart from carbon to nitrogen. I'm not going to give you details, have a glimpse. Calcium also required, magnesium also required, molybdenum, nickel, all particular things are being required. And no doubt these are always present in the biomass. If not present, you can add manually from the outside, because these essential micronutrients are also required along with carbon to nitrogen ratio. Okay, so this is something very much important. So this is something for formal design. I'm not going to discuss the design, but have a particular floating type. Okay, this is floating drum. You're going to be the water jacket. Why water jacket is there? See the water jacket. See this water jacket. Right. Water jacket is just here to remove the excess heat which is produced in the systems. When you want to remove the excess heat, the temperature is maintained. The temperature is maintained. The methylogenic bacteria will grow substantially in the systems. When the methylogenic bacteria grow substantially in the systems, they consume carbon and want to produce methane, and this methane is being collected at the top over here in the drum. which is taken out. Okay. So this is a routine particular parameters or design parameters, okay, which you can really take care. See this. This is fixed dome type. Sorry, floated dome type. See this floated dome type here, floated dome. What is actually happening as the gas pressure rises, this dome rises. Okay, this dome rises. The rising of dome is an indicator that gas is produced. Okay, you see, can do certain other experiments also, but generally when the drum rises, by default it's an indication that you know this gas is being produced. Okay. So this is the inlet beta, this is the inlet, and this is basically outline what I'm talking about. Okay, the fermenter is there. It's called fermenter. This is fermentation is going on, beta. Inlet can be side, outer the side. Okay, gas holder, gas outlet. Okay, and this is fixed dome type. You must have that with that. Okay, so fixed dome type, you are going to have a fixed dome type is like this dome type structure is there. I always ask my students suddenly why this is dome type structure. Okay, if you go through this particular slide also, this has a dome type. Okay, here if you see here's a dome type structure also. Why it's a dome type? I generally ask my students this question. I'm a mechanical engineer. This is a very well suited question to all of you. Why it's a dome type? Okay, dome types is basically you have a hemisphere. Okay, when you have a hemisphere, the radius at every point is same. You know very well. When the radius at every point is same, this means whatsoever gas is produced at the bottom here, uniformly distributed at each and every point. When it is uniformly distributed, no doubt there's no concern that the pressure is very high. Because otherwise, if you're not going to have a dome type structure, if you have a cone-like structure, the pressure at this point will be very high. The gas which is produced at the bottom is going to exert very high pressure at that point, and sometimes chance that it can rupture this, it can destroy this, there may be explosion like this over here. So that's why you have a fixed dome type, hemispherical type. The radius at each and every point is same. When the radius is same, no doubt the pressure is distributed uniformly throughout the dome, and you can take the gas hole. It's a fixed dome type. And the slurry, you know what is slurry? जो slurry बच गई डायरेक्शन होने के बाद, it's a very good manure always. It's taken out from here and collected and taken to the fields. And these are the some leading success stories or case studies where the biogas plant at the industrial scale is being implemented. So they have a very good amount of biomass that is being produced in systems, and they are using it for production of biomethanation. paper mill muxar. Okay, so they are using a black liquor. You know what is black liquor? Black liquor is basically पेपर मैन्युफैक्चरिंग में ना जो केमिकल्स होते हैं उसकी पल्पिंग के लिए, pulping के बाद also liquor is being left. It's a black liquor. Why is called black liquor? It's full of chemicals, very much laced with the chemicals. So they have designed the method to use black liquor. Huge. Otherwise, is black liquor treatment करने के लिए they're going to spend huge amount of money. So what they are doing, they're using black liquor for the biomethanation. So देखो biomethanation से जो gas produce हो रही है, and they are using this gas to burn it. While burning it, they are producing steam. So they are producing, they are saving in a double aspect. Black liquor को treat करने से बचा रहे हैं, biomethanation से gas बना रहे हैं उसको burn करके अपना fuel save कर रहे हैं, और no doubt industry is saving a lot. You see this 15 to 20% of energy requirement of mill produced biogas plant. It's huge, beta, huge. अगर 10 लाख बिल आ रहा है इंडस्ट्री का एक में ला लो 20% बेटे. और दूसरा जो सेविंग्स हो रही इलेक्ट्रिसिटी में, केमिकल कंजम्पशन में, लो सीओडी बीओडी इन वेस्ट वाटर. क्यों? अगर ये ब्लैक लिक्विड ट्रीट ना करते बायोमेथिनेशन में, कहाँ जाता है ये सारा ट्रीटमेंट के लिए? एंड यू कुड हैव स्पेंट इजीली ऑन द केमिकल, इलेक्ट्रिसिटी, पंपिंग, दिस वन. So you are saving there also, and it's a win-win situation for industry. No doubt. Okay. This is for you. I'm not going to discuss this thing. This is the actual facts of what is actually efficiency of that particular this biogas plant. I'm leaving this thing for you. Just go through. I'm always there to discuss this kind of thing with you. Okay. So these are the some natural resources, beta. You can go through, beta. The carbon rich platforms are there. You can go through the slide very fast. So these are basically we're talking about carbon rich raw materials. अब ये क्या है बेटा, मैं बताने वाला हूँ with time आपको. These are natural plant oils such as soybean, corn, palm, canola, all these things. These are being used worldwide for the production of biodiesel. I think so. I have given you some basic introduction during my previous particular lectures on biodiesel. Okay. What is biodiesel, beta? Biodiesel is an important commercial air emission reducing additive substitute for biodiesel. तो मैं आपको पहले बता चुका, बता बहुत पहले कि अब पूरा वर्ल्ड they are working towards biodiesel, producing biodiesel. क्यों? Because आपके जो natural resources हैं, petroleum, diesel, they are not going to last for they're not going to last for many years. They will be exhausted very soon. And as the population increases, as the demand increases, as your number of vehicles increases, your demand is always increasing. So you cannot rely upon these kind of resources as such. You need to look for the alternate sources of energy also. So this is the most common, answer to these kind of concerns. That's the formation of biodiesel. So biodiesel is basically a particular product which is produced from the edible and non-edible oils. I want to discuss. Edible oils means soybean, corn, all these kind of things are edible oils, canola oils. Okay, some canola oils being also used, and sometimes most of times it's like in the countries where the edible oils are not being used, produced so much, so they are working towards non-edible oils like India. I want to discuss these things throughout. Okay, so we are going to do the trans-esterification of this particular vegetable oils. Trans-esterification. This produce fatty acid and methyl esters. It's commonly known as biodiesel. अब ये बायोडीजल क्या करते हैं? ये सीधा गाड़ी में नहीं यूज होता. मैकेनिकल इंजीनियर्स आपका बहुत बड़ा काम है बेटा इसमें. पूरा वर्ड आपके लिए वेट कर रहा है, बिकॉज यू नीड टू मॉडिफाई द इंजन. बिकॉज आपको जो डीजल इंजन है ना बेटा, डीजल इंजन में आपको मॉडिफाई करना पड़ेगा. जो आपको उसमें डीजल ऐड हो रहा है, उस डीजल में बायोडीजल ऐड होगा. तो बायोडीजल कितना ऐड होना है बेटा? पहले 10% ऐड हो रहा था, फिर 20, फिर 30. इसको B30 बी बोलते हैं. B10, B20, B30, B40 accordingly. B30 means 30% blend with the natural diesel. अब सोचो, आप अब 30% लेस रिलायबल हो रहे हो नेचुरल रिसोर्सेज पे. जो एक्सट्रैक्शन है वो 10% कम, 30% कम हो गई है. सोचो 30% कम हो गई है, तो उसका मीनिंग ये है कि उनकी लाइफ बढ़ गई है 1/3, सॉरी 3 टाइम्स बढ़ गई है. जो 3 टाइम्स एग्जैक्टली 1/3 जो उसके अकॉर्डिंग बढ़ गई है. तो ये वर्ल्ड वाइड रिसर्च है कि हम कितनी ब्लेंडिंग और कर सकते हैं. बिकॉज ब्लेंडिंग जैसी बहुत करते हैं, बिकॉज इट्स नॉट अ नेचुरल डीजल बचे, इट्स अ ब्लेंडेड वन. ओके, फ्रॉम द प्रोड्यूस्ड फ्रॉम द नेचुरल दिस काइंड ऑफ थिंग्स. और इंजन मॉडिफिकेशन का सबसे बड़ा काम है, जो मैकेनिकल इंजन का काम है पूरे वर्ल्ड के. क्यों? if you are blending more, then there may be a wear and tear of the engine, because octane and CT numbers you have to maintain accordingly for the engine. octane CT number maintain नहीं करोगे तो नॉकिंग हो जाएगी तो इंजन की wear tear हो जानी बेटा, उस चीज के लिए, है ना. So with time it's being recognized that biodiesel is an eco-friendly alternative to diesel fuel prepared from the domestic renewable sources such as vegetable and animal fats. So these all oils or animal fats are made up of, no doubt, triglycerides, if you can go through this kind of. And these triglycerides, when they are being reacted with some amount of lower alcohols, not high category, high alcohols, okay, some lower alcohols, in the presence of some catalytic acid, they are catalyst, and they result in the formation of fatty acid acids, and which is commonly known as. Why? Because they are striking as properties not exactly similar to the petroleum derived biodiesel. Sorry, diesel. It's called biodiesel. Okay. So now, after producing this biodiesel, we remember that, so I totally work on the engineers, totally work on the mechanical engineers, because they wanted to have a mix of this biodiesel with the coconut. So once they have a mix with the simple diesel, you need to study the exhaust properties of the engine, the knocking properties of the engine, performance properties of the engine, and this is total work of mechanical engineers. Okay. So I told you, in US and developed countries, they are more leaning towards the biodiesel formation from the soybean or sunflower oils, and the production is very high. Where India is deficient in edible oils because we're exporting majority of the not sorry importing the majority of that kind of edible oils. So we are working on the non-edible oils like Karanjia, Jatropha, बहुत काम चल रहा है इंडिया में. Okay. So सबसे बड़ी बात है कि these kind of plants we're talking about, these plants, they can be grown on a very kind of wasteland. Okay, so हमारे यहाँ बहुत ऐसी wasteland available है, so we can have this kind of jatropha or karanjia or these kind of things, and the seeds can be used to produce इससे oil निकालते हैं, oil निकाल के इसको हम use करते हैं particular for the production of biodiesel. Okay, now go to this slide better very fast and come to that. Go through this very fast, beta. Just hold on, huh? Hope so. You have gone through this slide, beta. I think so. Okay. So this is something. Is a very good information that many automobile giants like Ford, John, okay, massive of Volkswagen, Mercedes, BMW, they have accepted biodiesel as a fuel suitable for their vehicles in the existing diesel engines. Okay. So as I told you, this is old slide basically. Now we have crossed 30% blend also. Most biodiesel we use is 10 or 20% blend rather than a neat biodiesel. Okay, neat is cannot be used, but okay, because it's substitute. Fine, it cannot be used. Okay, but we are working towards a maximum substitution, like B30, B40. We have reached more than 30%. Okay, So this is something I told you as per the slide I've given you. The biodiesel is one of the such candidate for the exploitation of the alternative road diesel fuel. Okay. So these are the some basic information for the biofuels. Like biodiesel, I discussed with you. Similar to the bioethanol. जो आपका पेट्रोल आ रहा है ना बच्चा, the petrol आ रहा है. Petrol is not a simple petrol. It's a blended petrol, beta. It's a bioethanol also. ठीक है जी. तो तभी आपका ये बायोडीजल जो आ रहा है सब कॉम्बिनेशन ऑफ डीजल और बायोडीजल और इथेनॉल जो सॉरी वो जो आ रहा है पेट्रोल आ रहा है इट्स मिक्स विद बायोइथेनॉल. ओके. तो तभी हम ये जो रिजर्व्स हैं जो बहुत लिमिटेड पीरियड के लिए रह चुके हैं हमारे पास. आपने पढ़ा होगा ना, हम पढ़ते थे, मैंने आपको बताया था पहले कि हम बोलते थे कि दे आर गोइंग टू लास्ट फॉर ओनली 20 इयर्स. ओके. बट दे आर नाउ लाइफ हैज बीन सब्सटेंशियली इंक्रीज्ड. हाउ इट इज बीइंग सब्सटेंशियली इंक्रीज्ड? द मोस्ट common thing is when we are looking for alternative fuels, and these alternative fuels can be used in combination of this particular conventional fuels, and they can mix with that and accordingly आगे ना वो चीज. So that's why you need to mechanical engineering का बहुत बड़ा aspect है इसके लिए जब बात करते हैं. You need to work on the engine modifications. क्योंकि ब्लेंडिंग तो 40% भी कर ले 50% भी कर ले, लेकिन भाई इंजन की मॉडिफिकेशन कौन करेगा? इंजन के सब साथ साथ अटैच है वो सब. ठीक है. So similarly, you have syngas. I told you in the last class, syngas combination of this thing can be converted to methanol. High temperature, high pressure can convert to methanol or liquid fuel, and similar to diesel. Okay. So these are the different generations. Better you can go through it. Okay. You can have sugarcane crops, you can starch crops, you can oil crops. You have different kind of raw materials. See this: sugarcane, directly sugar beets. All these can be directly converted to ethanol using fermentation and distillation. Simple. फर्मेंटेशन क्या होता है बेटा? ईस्ट डाल दिया इसके बीच में, ईस्ट डाल के उसको फर्मेंट कर दिया. ईस्ट क्या होता है? आपके सैक्रोमाइसिस सर्वेसिया बैक्टीरिया होते हैं और शुगर को कंज्यूम करेंगे, ऑक्सीडाइज करके उसको कन्वर्ट करके इथेनॉल कन्वर्ट कर देंगे. और इथेनॉल को रिमूव कैसे करना है? थ्रू डिस्टिलेशन. ठीक है. डिस्टिलेशन क्या होता है? डिफरेंट बॉइलिंग पॉइंट्स पे अलग अलग प्रोडक्ट बाहर निकलते हैं. यू कैन स्टार्च क्रॉप्स, बेस, व्हीट, ऑल काइंड ऑफ थिंग्स, एंड यू कैन हैव सैक्रिफिकेशन. सैक्रिफिकेशन क्या होता है बेटा? पहले स्टार्च को कन्वर्ट करते हैं शुगर पे. ये सब स्टार्च है, ये शुगर है, ये सब स्टार्च है. स्टार्च को शुगर में कन्वर्ट करने का जो प्रोसेस होता है इसका सैक्रिफिकेशन. ओके. एंड दिस थ्रू द सैक्रिफिकेशन यू कैन कन्वर्ट. क्या करते हैं? यू आर गोइंग टू यूज सम एंजाइम्स. एंजाइम्स के यूज करने से यू आर गोइंग टू कन्वर्ट द स्टार्च टू शुगर, एंड दिस शुगर इज अगेन द फर्मेंटेशन एज द सेम रूट आई टोल्ड यू, देन डिस्टिलेशन. देन you have oil, this tetropa, peanut, sunflower oil, and you do the extraction. oil आ गया, oil की esterification की जो भी बताई थी मैंने, esterification से सीधा बायोडीजल आपका आ गया. And accordingly they are being categorized accordingly: first generation biofuels, second generation, and third generation. Okay. First generation means these are made from, देखो this is the first generation, तो सीधे यार sugar से convert हो रहे हैं. These are made from the sugar grain or seeds. Okay. This is the first generation directly. Second generation जहाँ पे एक step ahead हो गया बेटा. Second generation is what? They are biofuels are those made from the land-based non-edible lignocellulosic biomass. और इसको convert किया ना हमने. We have lignocellulosic biomass. We are going to convert into the sugar first. Okay. Then sugar to then fermentation, then distillation. Okay. And third generation biofuels are those which require a considerable research and technology advances. Okay. Hydrogen based fuel, photoelectrochemical fuel production. There's so many other algal based, algal ponds सुने होंगे, algae से produce होता fuel बेटे, hydrogen produce होता है वो. ठीक है. So the third generation are which are requiring a considerable research, technology advances. ठीक है. इसके लिए बहुत एडवांसमेंट चाहिए था. तो आपको वर्कआउट करना पड़ेगा कि यार इंजन में हाइड्रोजन सेफ है. हालांकि हाइड्रोजन की जो कैपेबिलिटी है भाई, क्या उसमें पावर आनी है उस चीज के लिए. बर्निंग, आपको पता है बर्निंग कैपेसिटी हाइड्रोजन की है. Okay. And so we are really working towards, like whole world is really working towards the third generation biofuels. Third generation के लिए बेटा मैकेनिकल इंजीनियर्स का बहुत बड़ा रोल है. क्यों? उनको इंजन ऐसे बनाने पड़ेंगे जो हाइड्रोजन बेस्ड फ्यूल को, हाइड्रोजन नॉट सेफ, एक्सप्लोड हो सकती है गाड़ी. You need to work on these kind of things. Okay. So these are the some basic hardcore facts, market information regarding these biofuels. You can go through biofuel market developed last 5 years, and by may share 10% of water fuel by 2025. Okay. So you have no doubt, same time you have these benefits also बच्चे है ना. That's better air quality. क्यों नॉक्स सॉक्स तो कम हो ही रही है बच्चे हमेशा. क्लाइमेट चेंज पे नो इम्पैक्ट, लो इम्पैक्ट आ रहा है बिकॉज आप वो नहीं दे रहे सीधा है ना. सॉइल कंजर्वेशन, वाटर कंजर्वेशन. सॉइल कंजर्वेशन क्यों, आप प्लांट्स लगा रहे हो, जेट्रोफा प्लांट्स ये सब लगा रहे हो आप ना, न्यूट्रिएंट्स अवेलेबिलिटी हो रही है. सो यू हैव ऑल दिस काइंड ऑफ एडवांटेज आल्सो. These are the merits beta of biomass energy. I told you discuss भी कर चुका हूँ ना. Growth of biomass consume more CO2. कैसे बेटा पता है आपको? That released due to combustion, the purifying atmosphere. जितने आप प्लांट लगाओगे, जेट्रोफा, ये वाला जितने भी सनफ्लावर ये सब लगाओगे, लगा किस लिए? बेसिकली बायोमास प्रोड्यूस करने के लिए. अल्टीमेटली ये कार्बन डाइऑक्साइड कंज्यूम कर रहे हैं. कॉस्ट कम है, डिस्पोजल वेस्ट की सॉल्व होगी, प्रॉब्लम सॉल्व हो रही है बट वेस्ट की. ठीक है ना. So this is overall discussion beta in this particular this thing. Okay. In the next class, I'll try to start certain miracles because as far as the energy resources labels is done, ये हम कर चुके हैं. Solar energy, if you remember, है ना? We have done the solar energy in detail. So as far as the energy resources is concerned, we are done with the energy resources until or unless we're going to decide something later on. But till now, what we have decided among our teachers, I'm done with the energy resources. The only things left is your particular numerical portions.